How we doing, everybody? This is That Our Nerd back at it again with another algebra tutorial. This one today is just another practice problem using our different exponents rule and trying to simplify. This one is going to use every exponent rule, I think. And so let's go through it. This is probably a more complex problem than you might see. But I'm a firm believer in you do a difficult problem and then the easier problems seem even easier. So let's go through this. Our first one is to distribute our exponents out throughout our different monomials, I guess you could call them here. And so what we'll do is, again, this is a number. So this is like something raised to the first power. So this first rule, our power rule, tells us that we take our exponent and multiply it by the exponent that we're raising it to what power, right? So this is going to be, we keep our base, so we keep 6, and then we take 1 times -4. So our exponent is now going to be -4. So we have 6 to the -4. We'll take x to the 4th to the -4th power, so we'll take 4 times -4, which is -16. So we have x to the -16, -16. Y squared, so we take 2 times -4, we're going to have y to the -8. We'll do the same for this next monomial here. We could do 7, again this is to the first power, so we'll do 1 times -2, so we'll have 7 to the -2 power. Take x cubed to the -2 power, so we'll take 3 times -2, so we'll have x to the -6. And then we'll take y to the -3rd power and take that to the -2 power. So we'll take -3 times -2. -3 times -2 is a positive 6. We'll then divide this by the stuff down here. So we'll take the first power times 3. So we'll take 2 cubed. Take x cubed to the 3rd power, so that would be 3 times 3, which is 9. So we'll take x to the 9th. Take y to the -1 power to the 3rd power, so -1 times 3. It's going to be a -3. We'll take 4 to the 1 power to the -1, right? So that's going to be 4 to the -1 power. X to the -6 to the -1. It's going to be -6 times -1, which is a positive 6. We'll take y squared to the -1. 2 times -1 is -2. So now we've used our power rule for all these. The next way is we can combine like bases, right? By using our product rule. And so how we would do that is anything with a similar base, we add the exponents, because we're multiplying them together. You have to go along the same row, right, in the numerator and denominator. But yeah, so we have 6 to the -4 and 7 to the -2. You might think, because these are both numbers, they're like bases, but they aren't. Each number is a different base, so you cannot combine these terms. But we can have 6 to the -4, 7 to the -2. We can just move them together, kind of get them out of the way, right? Use our commutative property for multiplication. Then we have x to the -16 times x to the -6. So when we're multiplying these exponents, these bases with exponents together, what we do is we add our two exponents. So we take -16 plus a -6. So that'll be a -22. Do the same with our y. We have -8 plus 6. So this is going to be y to the -2. We'll divide this stuff by this other stuff. So 2 and 4 are different bases, so we cannot combine them. But we can do 2 cubed and 4 to the -1. And then we'll combine our x's and our y's. So x to the 9, x to the 6, right? We're multiplying them together. So we'll do 9 plus 6 is 15. So we have x to the 15. And then we have -3 minus, or a plus a minus 2, I guess you could say. But negative 3 minus 2 is y to the negative 5th. So now we will use our quotient rule. And what that tells us is that if you have similar bases, if you have like bases, you subtract the exponents. All right, so we'll still have 6 to the negative 4, 7 to the negative 2, divided by 2 cubed, 4 to the negative 1. And now we'll try to figure out our x and our y here. So we subtract our two exponents. We have negative 22 minus 15. So negative 22 minus 15 is going to give us x to the negative 37. And we'll take negative 2 minus negative 5. Well, we're subtracting a negative, right? So this is going to be like plus 5. So we take negative 2 plus 5 gives us y cubed. Now we want to make everything have positive exponents because it's much better that way. So what we do is change it to the numerator and denominator. So these numbers here have negative exponents, so we can move them to the denominator and make them a positive exponent. This 4 to the minus 1 has a negative exponent, so we can move it to the top and give it a positive exponent. So we'll take 4 to the negative 1, 4 to the negative 1 divided by 2 cubed. Sorry, this is not negative, right? We move it to the numerator to get rid of that negative, so that's a positive one. And we'll take 6 to the 4th and 7 squared. So that's the numeric, that's the number part. This negative 37, x to the negative 37, this means we can move that to the denominator and make it a positive exponent. So take x to the 37, and then y cubed is already positive, right? So we can leave that in the numerator. And boom shakalaka, there it is. Oh, there it is. Not so bad, right? If you go through it step by step and go through the process, it's really straightforward. And the more you use these exponent rules, the easier and easier it becomes. But you could simplify this down a little more by expanding these. I just kind of made up this problem off the top of my head, and I don't feel like solving what 6 to the 4th times 49 times 8 is. So I'm just going to leave it like that. But you could simplify this down a little bit more by multiplying. But you'd want to find each of these and then multiply them together. So that would be 8, 6 to the 4th, 6 times 6 is 36, times 6 is 216 or something, and shoot, I don't know, really big number. And this is 49, right? We'll just say for kicks and gigs that this is like 1,000 or something. It's probably a little more than 1,000. But once you have your three terms, you multiply them together, and that's the number. So thank you very much for your time. If you found this video helpful, make sure to click that like button below and subscribe to see more videos similar to this one. Thank you very much. You're a rock star. Have a great day.